So today we're going to do the log graphs, and you cannot log a negative value. And I should have written on here or zero. And I'm going to show you why, because we're just going to take a second and talk about domains before we jump into like doing an actual graph. You cannot log negatives or zeros. So let me just make up an example to show you why it won't work. So like, for example, say you had log base 2 of a negative number like -4. What that's asking you, and it's asking you for the exponent, if logarithm equals the exponent. What this is asking is 2 to what power would give you -4? Just think about it for a second. Is there any exponent in the world that'll give you a negative result? Like, no, that's just not going to work. Like, there isn't one. And then the same thing for 0. Like, say you did log base 2 of 0. Like, say you tried to log 0. What that's asking you is 2 to what power gives you 0? Think about it for a second. Even if you plugged in 0, what would be 2 to the 0 power? Be 1. Like, there's no number in the world that's going to work for either of these. So, like, it just won't work. You can't log negative numbers or 0. So that means your domain is not everything. You now have a restriction. Like, you have a rule that you have to follow. It has to stay above 0. So if it says find the domain, the only part you need to look at is the part that's inside the logarithm. The rest of it doesn't really matter because that's outside of the function. So you just need to look at the part that's inside. In this case, it's the x plus 2. So you're going to take whatever's inside and you're going to say, okay, it has to stay above 0. Why did I not do greater than or equal to? Why did I just do greater than? It can't be 0, okay? And then you just solve that and write your answer. I started with a really simple one. Bless you. What would you do to solve that? Yeah, minus the 2. Bless you. And so x has to be bigger than -2. And you just have to write that in your interval notation. So kind of like think about your number line. You've got -2 and you want everything above it. How would you write that as an interval? Good. -2 to infinity. And let's have the bracket versus parenthesis conversation. Good. Parentheses. This unit will have like no brackets anywhere because everything has asymptotes. So like just put parentheses for everything this unit. There will not be any brackets. For this one, oh, what's the base number for ln? E, good. And about what is E? As long as you know it's 2.7, I'm happy. As long as you know it's a number, actually, I'm happy, but it's like about 2.7, okay? So you're going to take what's inside the logarithm, the x plus 3 over x, and say, all right, that's got to be bigger than 0. This is, I put this on here to do review of our number lines. You're going to make a number line for the x plus 3. Do you guys remember this? And a number line for the x. Looks like you're drawing a musical staff, except it only has 2 lines on it. Oh, yeah. And we're going to put our pluses and minuses on there. So where does x plus 3 equal 0? Like, where is that going to have a chain? -3. And x, like, by itself would change at 0. And do you remember how we fill it in if nothing awkward happened? Negative and then turn positive. So they'll both be negative until they get to that number and then turn positive. And I'll try to use colors up here and it doesn't show up real great, but you're going to slice up your number line, put those little like balloon strings in there. And we want to look at what's the overall sign for the whole thing. So for the first section, what's the overall sign? Yeah, good. Negatives cancel. So this would be positive, and then negative, and then positive. And then here's the $1 million question, because that usually goes well. Which sections do we want? Which parts are our answer? The positives or the negatives? Good, because we want to stay above 0. So if it helps you to color it in, sometimes that helps people. We want these 2 positive sections. And so how do we write our answer? Good. -infinity to -3 is that section. Just parentheses for everything. Oh, union. Good. 0 to infinity. So the big takeaway here is it has to stay above 0. You can't log a negative or 0. And so the domain's not going to be all reals. What is going to be all reals? The range. Because remember how exponential and log are inverses? What did the exponential look like? What do I call it? A swoop? Okay, this is going to be a sideways swoop. Off to the side here, just like up here where your name goes. This is a way that people remember which one is which. If this helps you, great. If it doesn't, then just kind of forget it. The exponential graphs have the horizontal asymptote. And if you look at the letter E, it has 3 of these horizontal lines in it for horizontal. Logarithmic has the vertical asymptote, and the letter L literally is a vertical line. If that helps, cool. If not, don't bother with it. If you have something better, I would love to hear it. I get all my best tricks from my students, but you now have to remember which one is which. Okay, so let's come down here to the first graph. And we want to fill in like the automatic stuff. For logarithmic, your range is going to be all reals. For exponential, the domain was all reals. So for these ones, range is all reals. Fill in like that automatic stuff. And this is going to have a vertical asymptote. Now look it. It's typically at 0 unless you shifted left or right. So did this graph shift left or right? Which one? Because it's kind of backwards. Right 2. Okay, so do you see the -2 there went right 2? Again, it's kind of backwards. So you can go right 2, dot that in, and then we can fill that out on our information over here. So this will be x equals 2, and horizontal will be none. So again, remember when we did the exponential and you asked, why is the other line for the other asymptote even on there? Well, it's because one is one way and one is the other. So you have to know which one is none. So you have to put something on that line. It can be none or a frowny face or nope or whatever silly thing you want to write, but you got to put something there to show me it's none. Okay. Now, when you go to get points, you want to plug in for y and get x because it's backwards. Okay. So it would sure help a lot if there was a y in the equation. What is y with this? Do you remember when we did this with inverses? We switched x and y. We're going to do the exact same thing, except just don't switch them. Just don't switch the x and the y. Okay. But we are going to solve it for x. We want to do the problem backwards. We want x equals instead of y equals. Trust the process. Come with me on this. What would you do to start trying to get x by itself? You have minus the 3. So just come down here. We would have y minus 3 equals all the rest of that. And do you remember me saying you're going to get stuck? And then you're like, not me, I'm a genius. I'm not going to get stuck. And I'm like, no, you actually are going to get stuck. Like that's part of the problem. When you get stuck, what's the question that you ask yourself to get like unstuck? What is the base number? 4. It is 4 to the power y minus 3 equals what? X minus 2. Okay, so when you get stuck, the question is what's the base? And then what would be the last step there to get x alone? Yeah, add 2. Okay, so you have 4 to the power y minus 3 plus 2 equals x. We got x by itself instead of y. It's backwards. Go with it. So when you go to make a table of values, you're going to plug in for y and get x. With me here? Backwards. We're going to plug in for y and get x. So look at this. 3 would be a good number to choose to plug in for y. Do you see why I picked 3? Because 3 minus 3 will be 0. Anything to the 0 power, 1 plus 2 is 3. What's another number we could plug in for y? Like we want to do at least 3 of them. I would go 4, because if you do 2, you're going to get a negative exponent, which is sometimes good if you want to flip a fraction, but I don't want to get a fraction here. So let's do 4. 4 minus 3. 1. 4 to the 1. 4 plus 2, 6. And then I want one more. So let's do 5. 5 minus 3. 2. 4 to the 2. 4 squared. 16 plus 2. Now that's going to go off the grid. The reason that happened is because the base is 4. So like 4 squared is already 16. You're already getting large numbers. Remember how exponential grows really, really quickly? Okay, like that's why that happened. But we'll just plot the ones that we can. So 3, 3, be right there. And trace. And then 6, 4. And then 18, 5 would be like well over here. Do you get what I'm saying? Like way off of the grid. Okay. But it's going to be a sideways swoop. It'll look something like this. And if you just turn your paper, do you see how it looks exponential? Okay, because they're inverses. It's just an exponential that's been turned on its side. That's all that is. Once you have the graph, you can just look at it and get most of this stuff. So do you remember what I told you to do if you get stuck? Make up a graph. Invent one. If all of this matches your graph, then I can give you credit for this stuff. Okay, so it's very forgiving. All right, domain. We're looking left to right. It's not all reals. It's going to be from where to where? 2 to infinity, only parentheses. X-intercept, look it. Do you see how it does touch the x-axis, but we didn't plot it like specifically? We're going to have to work for that one, so let's come back to it. That one's going to be a little bit of work. Y-intercept, what do you think? Here's your y-axis. None, it just doesn't touch the y-axis, so cool. Are we increasing or decreasing? Okay, but it's not all reals because the domain's not all reals. So it increases for 2 to infinity. You're copying over the domain. The reason it was all reals for exponential is because that domain was all reals. But this one's not, so it's 2 to infinity. Sorry, that 2 wasn't very good. Let me fix that. All right, end behavior is a little bit different with how we write this too. Okay, let's do the right side first. Limit as we go to infinity, that's the right side. I know it's not real dramatic. I know it's like not in a great big hurry, but isn't this going to keep going up forever? Like, I know it's kind of lazy. It's not like very dramatic or anything, but it's going to keep going up. So what's our answer? Yeah, infinity, like it's headed upwards. Okay. Now you can't go to negative infinity. There's no graph over here. Do you see what I'm saying? So you can't go to negative infinity. You're fenced in. So the furthest to the left we can go is what number? 2. So its limit as x goes to 2. And I'm going to show you one other piece of notation. I won't take off if you forget to put this, but I'm just like letting you know because it's true. When you do limit as x goes to a number, you say which side it approached from. So did this graph approach from the left or from the right? From the right. Do you guys see that? So what you do is you put a little plus sign with it to show it was from the positive side. So its limit as x goes to 2 from the right of the function. If that made you uncomfortable, guess what? It's the first time you ever saw that notation. Wait till we do a couple more examples, right? As we go to 2 from the right side, where does that arrow point? Yep, down, so negative infinity. Now we have to go back and get the one thing we skipped. We skipped x-intercept, right? 2 plus, it's 2 from the right side. If it were going to 2 from this side, we would put a little negative to show it was 2 from the left side. Again, that's the first time you ever saw that. We have more examples on the other side of the paper. You're going to see it again. Okay. Now let's go back and get the x-intercept. It's going to be something comma 0. So you're going to have to take this whole thing and set it equal to, oh, I actually already rearranged it though. Something comma 0. We want to plug in 0 for y. I'm going to use my rearranged version because that'll be a little bit easier. If we plug in 0 for y right here, 0 minus 3 will give us what? Negative 3. So it'll be 4 to the negative 3 plus 2 equals x. Use the rearranged version because that's going to be a little bit easier. So what is 4 to the negative 3? That was on your Quizlet. It is a fraction. 1/64. Now you have to turn the 2 into 64ths as well. So here's the $1 million question. How many 64ths? Oh, good. And what would that be when you add it together? 129/64. So 129/64. Don't discriminate. That's a great answer. I actually really like that. Maybe 129/64 is my new favorite number. But let me recap how we got that. We plugged in 0 for y. That made this a negative exponent, so we flipped it, and then we got a common denominator, added it together. Cool. Let's try another one. Fill in the automatic stuff first. What is something over here that I can put in that it's like just the answer? Range will be all reals. And then you want to do the asymptotes. Now there will be a vertical one. It's typically at 0 unless you shifted left or right. Now it's kind of backwards. So what direction did this guy shift? Good, left 1. So go left 1, dot that in. And then you can put that information on your list here. Those are like the automatic answers. Like you should get that part. The rest of it, if you struggle to get points to plot, again, make something up and then just make your information match your graph, because I can give you credit for all this as long as it matches. So you want to plug in for y and get x. You want to do the problem backwards. So scribble out f of x, call it y. It's exactly like finding an inverse. You're just not going to switch the x and the y. I'm just going to kind of use the space in the margin up here. We're already stuck. Like if you're trying to get x by itself, we're already stuck. We're starting out stuck. So what's the question? What is the base number here, guys? 2, dose. All right, so it's 2 to what power? 2 to the y equals x plus 1. And then what would you do to get x by itself? Yeah, subtract 1. So it's 2 to the y minus 1 equals x. You're doing the problem backwards. It's an inverse. So solve for x instead of y. And then when you make your table, you're going to plug in for y and get x. Looking at this, what do you want to try to plug in for y? And if it doesn't work, we'll just pick something else. Oh, good. 0 is a good choice. I agree with 0. Here we go. 2 to the 0. 1 minus 1 is 0. You should actually be really, really happy about that. Why is that a really good thing? It's the x and the y-intercept. Like when you get the origin, like life is good. All right, what else do you want to try and plug in for y? 1 is a good choice. 2 to the 1 is 2 minus 1, 1. I know that I should have made this the first one because this one's actually easier than the one we just did, but that's all right. All right, and then let's do one more. What else can we plug in for y? 2. If you plug in 2, 2 to the 2, 2 squared. 4 minus 1, 3. And then you plot those, it should look like a sideways swoop. So 0, 0, 1, 1, 3, 2. So it should look like this. And then once you have that, just go and fill in all your stuff. Again, I should have made this the first example because this one's way easier than the one we just did. Domain, you're going left to right. So that would be where to where? Perfect. -1 to infinity. Your x and y intercept is 0, 0, which is nice. Are we increasing or decreasing? So you're increasing, but it's not all reals. It's -1 to infinity because that's your domain. And then the end behavior. Let's do the right side first because that one you'll be a little bit more familiar with. It'll be limit as x goes to infinity of the function. So the right side. And again, I know it's not super dramatic, but where is the arrow like on its way towards? Like it's going up, okay? It's not in a great big rush, but upwards is the direction it's gone. Now, this is the one you're less familiar with. So if you like got confused on the other side here, we're going to do it again. You can't go to negative infinity because there's nothing over here. You're fenced in. What's the furthest you can go? What number? Good. -1. Oh, and why a little plus? From the right side of the function. See, that went better that time. See how you have to see something more than once to get it? See how that works? And where's that arrow pointing? Down. So negative infinity. All right, so base is E. You're going to do the problem the exact same way, except you're only going to get 1 point instead of 3 points. So fill in your range. That'll be everything. And then what kind of asymptote is it going to have?
Negative.
Vertical, and it'll be at -4. Okay, because we went left 4. So go left 4, dot that in. And then you can put that on your list. Now you need to plug in for Y and get X. All right, it's backwards. So we're going to rearrange this so that it's X equals instead of Y equals. Okay. I'm just going to use this little bit of space in here. I might end up writing over the graph a bit. That's okay. It'll be all right. What would you do first to try and get X alone? +2. Okay, so it's going to be Y +2 equals all the rest of that. -ln X +4. Now, the next step's a little tricky. I'm going to ask first. I'll obviously tell you, bless you, if nobody gets it. But what's the next thing you want to move over? Because you're not actually stuck yet. Go ahead. You want to divide by the negative or multiply by the negative, however you want to think of that. So it's going to be negative Y +2 equals ln X +4. If you're like, hey, can I distribute the negative? Sure, that's kind of like a personal preference. I prefer not to because I feel like that makes it more complicated, but it's up to you. That's a you thing, okay? Now we're good and stuck. All right, what's the question we have to ask ourselves? All right, what is the base? E. So it is E to the power negative Y +2 equals X +4. And then what's your last step? Yeah, subtract 4. Good. So E to the negative Y +2 minus 4 equals X. So we successfully rearranged it. We're going to plug in for Y and get X. You need to think about what would be a clever number to plug in. Actually, there's only one that's going to work. What can we plug in for Y so that we can actually do this without a calculator? Not 2, but good, -2. And that's why I recommend don't distribute the negative sign, because I feel like that makes that harder to see. So here we go. -2 + 2. 0. You can't negative a 0, so it's just 0. E to the 0. 1 minus 4, -3. So that's the 1 point you get to plot. -3, -2. And then here's where everybody looks at me and goes, Miss Cole, now what? We have 1 point and an invisible line. Okay, and I get it. I totally get it, 100%. You have a 50-50 shot. The graph either goes up or down. So you look at the original equation. Do you see a reflection in here? Do you see that negative? Good, so it's going to be upside down. It's going to go down. There's only 2 ways it can go, up or down. And because we have the reflection, it's going to go down. But if you aren't sure, pick one and go with it. You got a 50-50 shot. All right, and then you're going to take that graph and fill in all the information. So domain, left to right, it would be where to where? -4 to infinity. X-intercept. First of all, is there one? Focus. Is there one? Yes. Okay, but we didn't plot it exactly. It's going to be something, comma, 0. and you're just going to plug in 0 for y. We did one like this when we did the exponential graphs. Some people really like this and some people don't. I recommend you get on board. Watch. You're going to plug in 0 for y, and just whatever you get is whatever you get because you're not allowed a calculator. Ready? 0 plus 2. 2, except it's, so it is e to the negative 2 minus 4. And if you were allowed a calculator, you could put that in the calculator and see what it is. It's some kind of decimal. Or can anyone do 2.7 to the power negative 2 minus 4 in their head without a calculator? Sure. No, so just leave it like that. I personally love that. Like, oh, I just get to leave that and walk away. Some people that bothers them that it looks like that, but just get on board, okay? Y-intercept. Is there a, first of all, is there one? Does this graph touch the y-axis? Yes, but we didn't plot it specifically, so it's going to be another one of these ones where we kind of just plug in 0 and then leave it alone. This time, though, you're plugging in 0 for x. So I would plug into the original one because you're plugging in for x this time. 0 plus 4. 4. So it's going to be negative ln of 4 minus 2. So negative ln of 4 minus 2, whatever that is. If you had a calculator, remember that ln button? You could type it in and get a decimal, but I don't know. I don't know what it is. It would be down here. It would be like negative 4, negative 5-ish, something like that. All right, are we increasing or decreasing? We are decreasing, but it's not all reals. Negative 4 to infinity. It's your domain. And then your end. Let's do the right end first because I feel like that's the one you're more familiar with. Limit as x goes to positive infinity. That's as we look to the right, where is this arrow pointing? Yeah. Down, so negative infinity. You can't go to the left all the way because you're fenced in. What's the farthest? All right, negative 4 from the right. So put a little plus sign because it's still from the right side. And where does that arrow? Positive infinity. One side's going to go up and one side's going to go down. We're just going to try one more. And I think I made this one easier than that one. Again, I should have put this one first, but oh well, that's good. All right, what's the automatic things that we can put? Vertical asymptote. Typically, it's at 0 unless you moved left or right. Did this graph move left or right? It actually didn't. So it's still going to be on 0. Yeah, and so that's a good point. That means what other answer is going to be none? Yeah, you won't have a y-intercept. So if you want to even go ahead and put none there, you can do that. And then what's the other thing we can put? Yeah, range is everything. You almost fill in like half of it without even getting a graph in there. All right, we're going to rearrange this so that it's x equals instead of y equals. We're not stuck yet. What would you move over first? Minus 1. So y minus 1 equals ln negative x. Then you're stuck. What's the question? What is the base? Bless you. So it's e to the power y minus 1, good, equals negative x. And then last step, yep, multiply by a negative, divide by a negative, however you want to say it. Basically just move the negative to the other side. And then what you do is you plug in for y and you get x. You're literally doing the whole thing backwards. But you have to be clever about what number you plug in for y. There's only one number that's going to work. 1. Here we go. 1 minus 1. 0. E to the 0 is 1, but it's negative 1. So when you plot that, you will notice, oh my gosh, it's where? It's on the other side. It's because of the negative. We reflected over the y-axis, so now your graph is over here. Watch. Instead of looking like this, do you see? It would look like this, but it got reflected. Now it's going to go this way. And then we're going to use that to answer all the questions. So domain, left to right. So that'd be where to where. It's on the other side now, so be careful. Oh, good. Negative infinity until 0. Is there an x-intercept? Yes. So this is going to be something 0. You're going to plug in 0 for y and walk away. Whatever it gives you is just whatever it is. You're not allowed a calculator, so you'll leave it alone. Here we go. Plugging in 0 for y right here. That'd be 0 minus 1 is -1. So it would be negative e to the -1. Whatever that is. If you can do negative and then times 2.7 to the power -1 in your head, anybody? No? Okay. Then just leave it. Are we increasing or decreasing? All right, decreasing, it's not everything, it's the domain. And the end behavior will be a little bit different this time because it's on the other side. You can now do limit as x goes to negative infinity because your graph is going off to the left. So limit to negative infinity would be what? Positive infinity. It's going up. Is everyone still with me? Because this is where we get to the point where some of you are still with me and some of you are like done, but just wait, okay? You can't go to positive infinity. You're fenced in. What's the furthest you can go? 0 from the left. So you're going to put a little negative there. And that arrow is going down. So negative infinity.